Welcome to Lyons Township High School AP Physics. We're going to do a quick example involving wave superposition or wave interference. In the previous example that we just did, we had waves of equal amplitude and equal wavelength interfering with each other. Hey, check it out. I'm waving at you. Look at that. All right. All right. Now, in this example, we're going to have two waves that are the same wavelength. Okay, just to show you, there's the same wavelength, but they're different amplitudes. Okay, and we're going to assume they're going the same speed toward each other. And let's say they're like water waves. And we're going to graph a couple things. First, we're going to graph, if this were, let's say, a fishing bobber or a piece of wood sitting in the water, what would its position be with respect to time? So if I videotaped this point, what would this point do as these water waves pass through it? Okay, so we're going to graph the height of that point, that fishing bobber, versus time. Okay, so imagine you're videotaping this. What's going to happen? All right, well, first these two meet. So at time equals 0, you got two equilibrium points meeting. So the fishing bobber is there. Okay, and then we'll look basically every half wavelength and see what happens. So when these have gone half a wave into each other, okay, you have a small crest meeting a big trough. Now, assuming that this is a height of, let's say, 1, and let's say this is a height of 2, this would be 1 and -2, so your result would be a -1. So sometime later, you're going to have a height of -1, okay, after half a wave is overlapped. Now, how about after a full wave is overlapped? Okay. Well, then, you've got that. That point is now two equilibrium points meeting. You're back to where you started. Okay. Now, how about when 1.5 waves overlaps? Well, now you have a big crest meeting a small trough, so the crest wins. And so you have a crest. And then how about when 2 waves overlap? Okay, you're back to equilibrium. 2 equilibrium points meeting, right? We'll keep going here. So now we've got 1.5 waves meeting. The last one was 1, by the way. All right, so we got 1.5 waves meeting. So what's this guy doing now? Well, you got a small crest and a big trough. Trough wins. And then you got an equilibrium point. Right there. So that'd be back to equilibrium. Okay. Now, how many times do you think this will repeat? Now let's try it out. Now you got your crest. Now you got your equilibrium point. Now you got a small trough. Now you got an equilibrium point. Then you got big crest, small trough. You got a crest. And then finally, you've got back to equilibrium. So if you were to graph the position of that bobber versus time, you would see that. And after that, the bobber would no longer be moving up and down. The waves are gone. So you get your 3 waves. Okay? But again, this is the height of the bobber versus time. Okay? So you kind of have to mentally run through that as the waves pass through each other. Okay? Now, something else that we can graph, and we did this in the previous example as well, but in the previous example, we graphed as the waves pass through each other, and we take a snapshot. So we stop the camera. and we look at what's the water look like over distance, over position, okay? So let me put these back to their starting spots. Okay, so now we're going to graph. We'll look and see what does this waveform look like when half a wave from each waveform is overlapped, okay? So imagine you've got a camera and you're going to pick a picture of the water at the moment that half a wave is overlapped. Okay, so now we're graphing something different. We're graphing the height of the water versus where we're at along the water. We're going to freeze time, okay? All right, so we're going to do half a wave. So there's half a wave overlapping, okay? So what are we going to see? Well, the part that's overlapping I'll do in red, okay? So you'd have a small crest and a big trough, so I would say it's a -2 and a +1. Well, you'd end up with a -1, okay? So between here and here, you'd have a small trough. Okay, that's where the waves are overlapping. And then everything else is just each individual wave. So starting here, we got, oh, another trough. Look at that. So I'll kind of mark these off, the equilibrium points. Okay, so you start with another trough, and then crest, trough, like so. Okay, I'm just taking this and recopying it down here. And then same thing over here. Starting here, you got a big crest, and then I'll mark the equilibrium points. So you have a big crest, big trough, big crest, big trough, big crest, like so, okay? And on this picture, these would have amplitudes of 2, these would have amplitudes of 1, and this would have an amplitude of 1, okay? All right, so that would be what you'd see if they were overlapped by half a wave. The last part we're going to do is what if they overlap by a full wave? What would our picture look like? Okay, so again, we're taking a snapshot, a still in time. Okay, and so we're gonna take a still picture that's not varying with time. So let's overlap them by one full wave and see what happens. Okay, so there's our full wave overlap. All right, what's our picture? If I take a snapshot now, what's our picture along the water going to look like? All right, so here's our still water. All right, so this point will be at no height because you got two equilibrium points meeting. Here, you're going to have a trough of 1 and a trough of 2 meeting, which will give you a trough of 3. Okay, so you're going to have big trough. And then you have an equilibrium point. Okay, and then the waves stop meeting, so I'll stop drawing there. Over here, you're going to have a crest of 1 and a crest of 2, which will add up to a crest of 3. So you have a big crest. And then there. So the middle of the pattern would look like that, okay? And then you'd have just each individual wave, okay? So you have this guy. Again, I'll kind of mark off the equilibrium positions there, 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 and there. And so those would each be a height of 1. And then these guys, again, I'll mark the equilibrium positions there, 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 and there. They'd have a height of 2. So you have a crest, or a trough, a crest, a trough, and a crest, okay? And just to kind of label some heights on here, where they're overlapping, these would have an amplitude of 3. The big wave has an amplitude of 2. And the little guy has an amplitude of 1, okay? So if you took a picture, in the middle of the pattern, you see this really big wave. To the left, you'd see the rest of this waveform, and to the right, you'd see the rest of that waveform. And you can continue that pattern, mesh them every half wavelength and kind of draw it out. So again, that's an example of wave superposition or wave interference. And we looked at both the height of this point versus time. And the second thing we looked at was the water, the vertical position of the water with respect to the horizontal position, meaning the we looked at a snapshot in time. We took a photo, a still photo. So I hope that was helpful, and thank you very much.